And here we need to talk about osmotic pressure, which you had learned in physiology how important it is. Osmotic pressure in the body fluid. Its osmotic pressure of a solution depends on the amount of osmotic effective particles in it. And we also have plasma. That's a specific aspect we need to pay attention to in human beings' blood and interstitial space. Plasma osmotic pressure contain colloid osmotic pressure and crystal osmotic pressure. And the osmotic pressure of extracellular fluid is roughly equivalent to ICF. So the water moves from area of low osmotality to area of high osmotality. You can remember it as water go from the low salty fluid to the highly salty fluid to dilute the very salty body fluid. So it'll be easy for you to remember. And when the osmotic pressure of ECF and ICF are equal, that will help to keep the balance of body fluid distribution in and out of the cell. Normal plasma osmotic pressure is 280 to 310. And what are the regulation of water-salt metabolism? Water balance is regulated primarily by antidiuretic hormone, ADH. And what's the function of ADH? From the name, and also from what you remember last semester. What's the function of ADH? Is to make you get rid of more water or to keep more water within your body. Yes, it's to keep more water in your body. And the perception of thirst helps you to search for and drink more water to increase water in our body fluid. And the sodium balance. The sodium balance is regulated by aldosterone. And how are they regulating the sodium and water? Here is a chart. Regulating mechanism, thirsty center and ADH, antidiuretic hormone, and aldosterone. What are the functions we've mentioned already, okay? Please keep that in mind. At the same time, follow me. Effective stimulation, like dry mouth, and extracellular osmotic pressure increase or extracellular fluid volume decrease. Will stimulate the person to drink more water. That's the regulating mechanism of thirst center. And the extracellular fluid osmotic pressure increase means more salty. And ECBV, effective circulating blood volume, decrease, and blood pressure decrease. That means we need more water to dilute this body fluid. So the reabsorption of water in renal tubules will be increased. That's how ADH regulates the water and salt balance. Then let's have a look at aldosterone. The ECF, extra effective circulating blood volume decrease. For example, you had a terrible bleeding, and the RAAS, renin-angiotensin aldosterone system, will be activated, and it will lead to reabsorption of sodium in renal tubule. And ECF, sodium drop and or potassium increase will have the effect of reabsorption of extra sodium. And since the name of this chapter is called Disorder of Water and Salt Metabolism, we are going to explain it separately. And disorder of water metabolism first. Here you need to learn 3 words. They are hypertonic, isotonic, and hypotonic. When the body fluid volume drops, it's a dehydration. Either is hypertonic or isotonic or hypotonic. When the body fluid volume increase, that's salt intoxication. And the body fluid is hypotonic. And the edema, when the body fluid increase, the patient suffer from edema. At that situation, the body fluid is isotonic. When the water intoxication happens, the body fluid volume increase, but the osmotic pressure is not increased. The body fluid is hypotonic. So compare the body fluid volume change. No matter it's hypertonic, isotonic, or hypotonic, when the body fluid volume is decreased, they are all dehydration situation. And when the total body fluid is increased, if there is lots of water in it, lots of salt in it, it's a hypertonic body fluid. And the situation is called salt intoxication. And if the body fluid volume increased, but the osmotic pressure stays the same, it's a isotonic situation that's called edema. And when the body fluid volume increased and within the body increased body fluid, the increase of water is higher than the increase of salt, means the whole body fluid is less salty than before, so the osmotic pressure is lower than normal. That's hypotonic. Let's talk about the body fluid decrease situation. Forget about hypertonic, isotonic, or hypotonic. They're all called same situation, and one situation is called dehydration. What is dehydration? It's an excessive loss of body fluid resulting from various causes. It's termed dehydration. Please keep this in your mind. And all the yellow letters, words to pay attention to. And we have hypertonic dehydration, isotonic dehydration, and hypotonic dehydration. Hypertonic dehydration. Let's have a look at the concept. The dehydration is which water loss is in excess of salt loss, and remaining ECF of the body is hypertonic. Is termed hypertonic dehydration. And hypertonic dehydration characteristic is loss of water is more than loss of salt. Serum sodium level is increased more than 150 milli50, and the plasma osmotic pressure is more than 310 increased, and may have cerebral hemorrhage, may lead to cerebral hemorrhage. And hypertonic dehydration causes are inadequate water intake, for example, inability to drink, or loss of thirst perception, for example, brain injury, you don't feel thirsty anymore, and unavailableness of water, for example, you're walking in the desert or in an ocean accident, you don't have fresh water to drink. And hypertonic dehydration can be caused by inadequate